Okay, today's lesson is 2.4b, zeros of polynomial functions. But in part A, we concentrated on the real zeros of polynomial functions. The real zeros are the ones that cross the x-axis. Today, we're going to talk about the complex zeros of polynomial functions. They will not cross our x-axis, but they still often create curves in our graphs, so it's important to know them. And one of the reasons is we want to know them because it leads us into the fundamental theorem of algebra. Okay, now what is so important about the fundamental theorem of algebra? Kind of a nice check-in point. Whenever you have a polynomial greater than of a degree greater than 0, then whatever the degree is, that's how many zeros the function will have, or roots, however you wish to think about it. Okay, so you're going to see we're going to be practicing that, and you're going to see as we go along. And another thing that goes along with that, in the previous lesson, we stopped when we had quadratics that couldn't be factored or knew that we didn't have a real solution. But now we're actually going to go carry forward with the linear factorization theorem and show you how any polynomial can be written as a product of linear factors. And linear factors means there's no exponents whatsoever in the factorization. Okay, now to be able to do that, we got to talk about something called the conjugate root theorem, which you saw again at the end of the last lesson, part A of this video, that whenever I had positive 3i, I also had negative 3i because it's coming from that square root or a quadratic. So what you want to remember about the conjugate root theorem is that complex roots always come in pairs. If I have a plus bi, then I'm also going to have a minus bi. And that's important when you actually have to write a function given the zeros. Now, before you found those zeros from the graph, but that's because they were all real zeros. And remember, complex zeros aren't going to cross the x-axis, so we aren't going to know what they are by looking at a graph. So this is doing it when you are just told what the actual zeros are. So we are to write a polynomial function of least degree with real coefficients in standard form with the given zeros. So in 6a, I have negative 3, 1 with a multiplicity of 2. And I hope y'all remember when I ended and I showed you that video, when it has a multiplicity of 2, that means that when it hits the x-axis, it bounces back and looks kind of like a parabola at that point, which means I'm going to have a squared on that factor. Okay? And if we have 4i, then that means I'm also going to have negative 4i. So let's talk about how we're going to do this. Okay, so first off, to kind of go backwards with it, if I have a 0 being negative 3, then I know that x equals negative 3. And I know that x equals 1. And I know that x equals 4i. I didn't want to go that far with that. Go back. Let's go to here. Wait. Okay, I'll deal with that. And I also have x equals negative 4i. Okay, now, when you have real numbers, these are real numbers, those are the ones that cross the x-axis, then I'm going to set each of those equal to 0. So I'm going to add 3 to both sides. I'm going to subtract 1 from both sides. Okay, if I have an imaginary root, an I involved, I'm going to square both sides. I'm not going to set it equal to 0 first. I'm going to square first. And the nice thing about this process, y'all, because you get 4i and negative 4i from squaring it, you only have to do it to one of these, okay? And then it'll take care of the other one. So when I square it, I get x squared equals 16i squared. Well, what is I squared but negative 1? So that's x squared equals negative 1, which then gives me x squared plus 16 equals 0. Now, why do I have these green parentheses around things? Because whenever you get a factor equal to 0, like I do here, then if you think about putting parentheses around it, those are the factors of your polynomial. So you can write f of x, or you can write y equals, but I'm going to have x plus 3, then I'm going to have x minus 1, and then I'm going to have x squared plus 16. And that is my polynomial. Set it equal to y, or set it equal to f of x. Okay? So in this next one, I'm going to have x equal to 2 square roots of 3, x equal to negative 2 square roots of 3, x equals 1 plus I, and x equals 1 minus I. Now, remember, as I said over here, okay, when you have an I, Yes, I need to know both roots because sometimes the question could be asked of you in such a way. You need to remember that if you got plus 4i, you got negative 4i, okay? Which is the same kind of thing here. They told it to me here. But if I have 1 plus I, the conjugate is 1 minus I. But I'm going to show you a little trick that'll help it easier to come up with the equation, okay? So when I have radicals and when I have a complex number, okay, I'm going to go ahead and square both sides. And when I square both sides, 2 squared roots of 3 squared. Need those parentheses when you put it in a calculator, y'all, or it won't do it correctly. So that gives me x squared equals 12. And if x squared equals 12, then I set that equal to 0, and x squared minus 12 equals 0. Okay? But remember, the fundamental theorem of algebra, y'all, that's a second degree. I have 2 roots from this equation. What are my 2 roots? 1, 2. So I've taken care of both of these roots with this right here. Okay? Now, come over here to x equals 1 plus I. And just like I did over here, I'm going to kind of isolate the I. So I'm actually going to subtract 1 from both sides. And then I'm going to square both sides, just like I did in that first one. Now, back to what we did before, y'all. This is that pattern that I told you about, one of the special cases in multiplying. So I'm going to square the first term, keep the sign the same, multiply them together times 2. So x times 1 times 2 is 2x. I have the negative because that's what's already up there. And then I square the last term, which is always positive, and I get 1. I squared, well, I wrote I squared, but that, of course, is equal to negative 1. So when I set that equal to 0, I'm going to get x squared minus 2x plus 2 equals 0. So I have both of my factors equal to 0. So I'm putting my parentheses around it, and I'm going to see that y equals one factor times the other factor. And there I have my polynomial function. Okay? Now, as you saw at the end of the video last time, sometimes there's an a value from that graph, but if they don't give me another point, this is all that we have to do. Okay. Now we have to talk about finding those zeros or factoring polynomials. Sometimes you're going to have a quadratic expression that is what they say irreducible over the reals. An example of that looks like kind of what we had before. X squared plus 4. We had an x squared plus 9, okay, in the previous lesson. Or x squared plus 6x plus 10. Both of those are irreducible over the reals. This does not factor over the set of real numbers. This does not factor over the set of real numbers. Neither one of these, if you made it equal to y and graphed it, would cross the x-axis. Okay? So, this is what we're going to do. These are the last 2 examples, y'all. Write each function as a product of linear and irreducible quadratics, then as a product of linear, and then list all the zeros. So we're kind of putting everything together that we've been doing. So 7a says f of x equals x to the 4th plus x cubed minus 26x squared plus 4x minus 120. So the first thing I want to do is find the possible rational zeros. Okay, and that's taking the factors of this number and putting it over, well, thank you, it's a 1, so all we have to worry about is that, which are a lot of numbers. Okay, so if you have a really high number like that with a lot of factors for it, then I'm going to go look at the table. Okay, so I went ahead and made my table with ClassCalc, and you can see I have a 0 here and a 0 here. We have one at -6 and one at 5. So those are my possible rational zeros, and that's where I'm going to start my synthetic division. So second step, synthetic division. I've told you before, I like to start with the positive numbers because fewer mistakes. My coefficients, I'm copying my coefficients down, and I'm looking 4, 3, 2, 1, 0, so I don't need any 0 placeholders in here. Okay, and my table told me I was going to get a 0, so I know a 0 is right here, and I know this is going to be 120. So now I'm going to go back and start, carry down my 1. 1 times 5, 1 plus 5, 5 times 6, -26 and 30, 5 times 4, 4 plus 20, and 5 times 24 is 120. So we're good, didn't make any mistakes. Next, I'm going to go with -6. So remember, I want to use the reduced polynomial or depressed polynomial, whichever one helps you remember. don't start back over with this guy or you'll be working for a long time. So I'm going to go with -6. Again, I know it's got to be a 0. So this is going to be -24. I'm going to carry down my 1. 1 times -6. 6 plus -6. 6 times 0. 4 plus 0. And then 4 times -6 is -24. So we're good. And when you've come down to 3 terms, if you haven't figured it out now, that is a quadratic. Okay, we started with a 4th degree, then we go to a 3rd degree, and now we're down to a 4th degree, and I didn't turn off my notifications. Excuse me, now we're down to a 2nd degree. So this is 1x squared plus 4 equals 0. Okay, so I'm going to write that. I'm going to subtract 4 from both sides, and then I'm going to take the square root of both sides and get x equals plus or minus 2i. So part A says, write it as a product of linear and irreducible quadratic factors. So my linear factors, this time I'm using f of x because that's what he started. My first one up there in green is x minus 5, because the factor and the 0 are always opposite signs. So x minus 5, the next one's going to be x plus 6. And then the last one, irreducible quadratic, is going to be the x squared plus 4. Okay? Part B says, give me a product of linear factors. Well, that's where this is going to come in hand. Okay? So instead of having, I'm going to have the same thing I had before. Okay? But instead of having x squared plus 4, those zeros, I'm going to have x plus 2i and x minus 2i. So that is how this thing factors. It's the difference of 2 squares, just like we've talked about before, y'all. But because of the I, it becomes plus. Okay? And then last but not least, what are the zeros? So my zeros are going to be the opposite of each of these factors. So my zeros are 5, -6, and then plus or minus 2i. And that's all we got. Oh, go away. All right. 7b. We have f of x equals x to the 5th minus 2x to the 4th minus 2x cubed minus 6x squared minus 99x plus 108. That's a 5th degree. That's a lot. But again, I'm starting with the factors of 108 over, yay, it's over 1, so I don't have to worry about any of those fractions. So my possible rational zeros, again, really big numbers, so I'm going to go look at a table. And I created my table with class calc. I'm looking for the zeros in the y column. That's what I've got. So from here, I'm going to start. Again, I start with the positive number. Oh, I missed that one right there. There's one. So I have 3 of them. All right, that's good. So I'm going to start with 1. It doesn't matter which one you start with, y'all. Okay, so I'm going to start with 1. I am writing down my coefficients, 5, 4, 3, 2, 1, 0. Okay, so I don't need any 0 placeholders. I know it's a 0, so I'm going to get 0 here, which means that's going to be -108. Again, just making sure I don't make any mathematical mistakes. So I carry down my 1. 1 times 1 is 1. -2 plus 1. 1 times -1. -2 plus -1. 1 times -3. -6 and -3. 1 times -9. -99 minus 9 is -108. And 1 times -108 is -108. So we're good. Now I'm going to go to the next one. I'm going to go to 4. So plug in 4. Again, I know it's a 0, so that's going to be +108. So I'm going to carry down my 1. 4 times 1 is 4. -1 plus 4 is 3. Times 4 is 12. Plus -3 is 9. Times 4 is 36. Plus -9 is 27. And 4 times 27 is 108. So we're good to go. Now, if you're really good at factoring, you might notice that factors, but I think a lot of people don't. So I'm going to keep going. And I have it. I have it in my table, so you might as well keep going. So I have -3. And so I'm going to use that. Again, I know it's a 0, so that has to be -27. Carry down my 1. -3 times 1, -3. Plus 3 is 0. Times -3 is 0. Plus 9 is 9. And -3 times 9 is -27. So we're good. And I'm down to where I only have 3 numbers here. in orange only have 3 numbers outside of my remainder. So that means I have a quadratic equation, okay? The first one was a 5th degree, then I got a 4th degree, then I got a 3rd degree, and now I'm on 2nd degree. So this is x squared plus 9 equals 0. If I subtract 9, take the square root of both sides, and x equals plus or minus 3i. So part A, write as a product of linear and irreducible factors. So this is when I'm taking these numbers here to write my factors and this quadratic, because that quadratic does not factor over real numbers. So I'm going to have f of x equals x minus 1, x minus 4, x plus 3, and then x squared plus 9. Second part says write it as a product of linear factors. So my x squared plus 9 has to be factored. So I hope you're already telling me that f of x is going to be x plus 3i and x minus 3i. And that makes my zeros 1. It's always the opposite of the factor. 1, 4, negative 3, and then plus or minus 3i. And that is all there is to finding complex zeros of polynomial. Hope y'all enjoyed that. Please don't hesitate to come see me or your teacher. If you have any questions, contact us. Thank you so much, and y'all have a great day.